Hey class, today we're going to be covering how a production possibilities curve works. Now, this is a main concept and graph that we're going to use to show a lot of different concepts that we learned in this class, have already learned. We'll kind of focus on the future. So you should have your worksheet about your production possibilities curve right here. You should have 4 graphs. Now mine are zoomed in because I got the big screen, but follow along on yours and we'll kind of go from side to side. Make sure you have your name, date, period already filled out. And we'll start on this graph here. So the first thing we need to know is we have an XY axis right here. And to give us an idea, we'll think of some kind of new types of goods. So you can kind of pick your own, and if they don't really make sense on these first few examples, that actually might work in your favor. A popular one when you think of 2 goods any economy can produce is kind of this one we learned in history class here where we talk about guns and butter. So you can fill your first one, the top left, of guns and butter. Now, what we want to think of now is we are an economy. So you can think of your whole class as an economy, remote, isolated, that will all work fine now. And in our economy, we only produce 2 goods, guns and butter. You might be thinking, hey, what else? We can't just eat butter and we need other machines besides guns. And remember, this is a very simplified idea for what our economy is. So we're just going to use 2 variables. Even though our economy has many, many, many more, 2 will work and simplify everything for us right now. So the way to think about it is this. We can put all our resources into making guns and we could make a certain amount of guns. So let's go ahead and say we could start here with something like 10 guns. Or we could invest our resources in making butter. And if we decided to make butter, that went a little weird, hold on one sec. If we decide to focus on making butter, we could end up with something like, let's call it 50 butters, okay? So 10 guns, or we could have 50 butters. Now what this curve represents is all the combinations of guns and butter that our economy could produce. So we could go ahead and have a point like right here, which would be something like 9 guns, and that would probably be about 20 butters. Let's call this point A, okay? We could also possibly have a point B here where we would have, here, and I can give you tiny ones. Let's say that's 9 and 20 here. So 20 butters, 9 guns. At point B, we could be right here. That would be about 6 guns. And that looks like something like 40 butters. We could have point C right here, and that could be 50 butters, but 0 guns. We could even have point delta right here, which would be 10 guns and 0 butter. It depends on what we're doing in our economy. If we're at like super duper peacetime and everything's great and all I want is butter, point C might be our best one. Maybe we're at war and we have no use for butter. 10 guns might be best for our economy. Or maybe we just have some combination inside. Now, this first graph here, this is what you need to put at the top, shows the concept of efficiency. So right now, you're going to want to go ahead and put, this graph shows efficiency. Okay, so with efficiency, this graph is going to show what is efficient and not efficient, or inefficient. So let's go ahead and add a few more marks. Let's say we were producing something like here, okay? And let's call that point echo, so E, all right? Now at this point, we could have something like, let's call that 8 guns and 15 butters. Now point echo is really important because if we were producing at 8 and 15 in our economy, we'd be very inefficient. We're inefficient because we'd only have 8 guns and 15 butters. Now, for no cost, if we just went and said, guys, let's use our resources more efficiently, we could produce at point alpha and have more guns and more butter, and we don't have to give up anything to get that. We just need to be efficient. So point echo would be inefficient, or like a recession, okay? On the other hand, we could also be somewhere out here, like Let's call that point Foxtrot. And at point F right there, we're outside of the curve. And now the point to remember per point Foxtrot is if all resources remain the same, what we call ceteris paribus, that'll come up later. But if we have ceteris paribus, if everything remains the same, point Foxtrot is impossible. Remember, this curve is called the production possibilities curve. That's what this green thing right here is. So this is the amount of production that is possible. We said this is all the combinations we can possibly make. So the curve is what's possible. So we could do point A or B or C or D. E is possible, but inefficient. And point F, well, that is impossible. Okay, so now on your paper, you should have drawn this whole thing along. On this graph, the numbers aren't terribly important, but you should have all your points here. And what you really want to do is this. On the bottom down here where it says, what is this graph showing? Elaborate what this graph is showing. This graph will make a major portion of your next test. It'll definitely be on the final exam as well, several questions. Don't forget it now by going, yeah, I see it, I'm not going to write anything. Write it out so you can look back and go, right, this is what it means. So what should you put? What is this graph showing? Well, we know the graph is showing efficiency, but how? So you might want to say, on this graph, I have points echo, which is inefficient. And you're going to want to put, why is it inefficient? If you're not sure, rewind the video. You also will want to put points alpha, Bravo, Charlie, and Delta. Those points are all on the line, so they would be efficient. So you might want to make sure you explain how they're efficient. And lastly, you have point Foxtrot. Point Foxtrot is impossible, but why? Again, if you're not sure, rewind the video. Now's a good chance to pause, write your answer thoroughly down here before this graph disappears. Goodbye. Okay, so our next graph is going to be over here. And we'll go ahead and pick some other odd items that we can use. And for this one, we'll go ahead and do something a little different. Instead of guns and butter, we can think of something like bagels and roller skates. All right, now make sure you're copying this around on your graph, because if I draw a graph, you draw the graph. Now on this, we're going to have another production possibilities curve. So we'll go ahead and we'll make a curve, and it'll what we call bow outwards. That means bow means bend outwards. And on this one, we're going to show the concept of economic growth, okay? So what we want to do is put this one, it's going to be economic growth. All right. Now, on this one, we can go back and put some of the points that we had before. So we can put point alpha, point Bravo, put point Charlie. We can even put, echo back in here, the inefficient point. But what we're going to do is we're going to go ahead and add point Foxtrot right here, okay? And we can even go along and say, hey, we'll be really slick here. We'll say this was 9 bagels. Down here, we'll call that 20 roller skates. We can say point B is 6 bagels or 35 roller skates. And we'll just kind of leave those right there. All right. So draw this on your paper and just imagine our economy. Our economy makes 2 goods, bagels and roller skates. And we can put 50 and 10 right up here just so we remember the same numbers. Now what we want to do on this one is, let's imagine our economy. We make 2 goods, everything on the curve is possible and efficient. Things inside the curve would be inefficient, and anything outside the curve is impossible, so long as everything remains the same. It's going to be important. Now, let's say all right guys, let's start producing. And we produce 9 bagels and we produce 20 roller skates. I say, all right, we're at point alpha, 9 and 20. Good job, guys, we're efficient. And then the next day I say, hey, I want more roller skates. So we make 35 roller skates, but we have 6 bagels, that's good. We're on the curve, everything's lovely. Maybe one day you guys produce 6 bagels and like 18, a little 18 right here, 18 roller skates, and I'd say, that's inefficient, guys. We gotta sharpen up, find the problem, and maybe we go back to 9 and 20 and everything's good again. So I'll erase that inefficient stuff, we wouldn't be doing it. So we can go from A to B, we could even go down here to C. That would still be efficient. Now, with that being said, let's say one day I say, all right, I look at how much we produced and I realize that we made 9 bagels, that's good, but we made 35 roller skates. Okay, that's interesting because that would be 9 and 35. That puts us right here at Point Foxtrot. Now I might go, hey, that's impossible. But I check my numbers and oh my gosh, look, we're at 9 and 35. Another day goes by and you do it again. You guys produce 9 bagels and 35 roller skates. Good job, I like that. But that should be impossible. But you guys keep doing it. So what must have happened here? Quick answer is something in our economy changed. We're producing more than we thought was possible. Okay, but if something's impossible and you do it, well, then it must be possible. But this has to make us rethink this curve. This curve is production possibilities. This shows us what's possible, but we're out here doing the impossible. Which, what does that mean about our purple curve here? In short, it means our purple curve must be wrong. It can no longer be what is possible if we're going outside of it. So what we need to do is move our curve. And what we'll find out is that the purple curve is inefficient and this new blue curve is efficient. And what did our economy do? Well, it grew. So now we have a growing economy where we're able to produce more bagels and roller skates. So when we talk about our economy growing, like even the US economy, which is maybe more complicated than this, it means we're able to produce more combinations of everything. So this could be due to things like technology, additions in human capital, or even things like additions to land, labor, and capital, what we call the factors of production. So what could cause this to happen? Increases in factors of production, human capital, and increases in technology. All right, now again, you should have already had this drawn, but what do you need to do? You need to go to what is this graph showing and explain what is this graph showing. We know it's economic growth, but how is it showing economic growth? And what could have caused this economic growth? Again, if you were like, I don't know the answer, I'd rewind a couple minutes, look at the video again and go, I see it, and make sure you elaborate, okay? Don't just put, it shows economic growth because it grew. And that's not gonna be full credit. So pause the video now, write out your answer, we'll move on to the next graph. All right. What we'll go ahead and show on this graph now, so we'll go bottom left, I know this kind of flipped around. So is we'll pick 2 goods, and you know what? For this one, I'm just gonna go ahead and pick very generic names, because sometimes tests will do this too. We can say good Y and good X. Okay? So what we'll go ahead and do is we will draw this curve, nice bowed out curve, that'll be lovely. And I'll go ahead and put some numerical values. So be careful when you're drawing this one and make sure all the things line up. So kind of watch as I draw it yourself, label everything, that's important, and we'll move on from there. So I'll go ahead and have my 10, and I'm gonna make my font size a little smaller. and I got this 9, and I got a 6 here, and I can go ahead and put my 20 here, my 35 here, put my 50 there. And to make this all nice and neat, we can go ahead and say, all right, 9 and 20 should line up together. 6 and 35 should line up together, and we'll call this point alpha, point Bravo. We'll call this point Charlie, and back up here, we'll call this point Delta, right here at the 0. Okay, and I'm gonna put a 0 right there just to make sure we're honest, and you guys know that obviously where the two axes meet, that's 0. Okay, now that you have this drawn out, again, make sure you line everything up. Pause the video right now if you're like, I need a moment. And let's go over this new concept here that we call opportunity cost. Oop. All right, we've already covered opportunity cost and said that opportunity cost is the value of the foregone option or the value of the next best option. Okay, so keeping that in mind, we can go ahead and look at this, and let's go ahead and say we're producing at point alpha right here. Okay, we're producing 9 good y's and 20 good x's. Okay, not bad. And again, this could be any two objects you want. But let's say for some reason, it can be any reason, I go ahead and say, you know what? I want 15 more good x's. Okay, so give me 15 more x's. So if we're at point A, we're making 9 y's, 20 x's, and I want 15 more x's. Well, 15 more of 20 is 35. Okay, so I gotta get to here, 15 more, so that'd be plus 15. Okay, but what do I do next? Well, hold on. If I make more good x, I can't make as much good y. I have limited resources. My land, labor, capital, the things I need to make stuff, if I direct more workers and more resources and more land and more factories to making this good, I can't make as much of the other. So I've got to give up something to get something. So to get more of good x, I sacrifice how much good y? Well, the answer is, it's the difference that you go to here. So remember, we're going from A to B because we go from 20 to 35. We assume efficiency. Therefore, we go from A of 9 y's and we go to 6. So we lost 3 good y's, okay? That is the opportunity cost. Because if went from A to B, so we're at B, what's the next best option from B? Well, it's A, where we were. So what did I give up to get 15 good x's? The cost is 3 good y's. This is an important one, and you're going to be expected to do the math. Now, let's go ahead and change it a little bit again. Let's say we're at point B, and I want 15 more good x. What would that cost me? So if I say, hey, we're at point B, and I want 15 more good x's. Solve. All right. The correct answer here would be, did you get it? 6 good y's. So I said, what's the cost of 15 good x's if we're at point B? That is how questions on the test work. The answer is 6 good y's. The answer is, if we go from point B and I want 15 more, well, 15 plus 35 is 50. So I've got 15 x's. What did that cost me? Well, if I'm here, how many good y's do I have? The answer is 0. So I had 6, I have no more, I get lost 6. Hopefully this is starting to click with you guys. And what I can do is, let me clean this up for a moment and say something to the effect of, let's say we're at point Charlie here. And I want 9 more good y's. Okay, so we're at Charlie, start there. And I want 9 more good Ys. What would that cost me? So that's the question. Start here, I want 9 more good Ys. What does that cost me? Try to solve it. Okay, let's see how you guys did. So you look here and you go, okay, I have 0 good Ys at point C, because we can go right over and say, yeah, we have 0. But he wants 9 more, so we got to go to 9. So what point will we be at? We'd be at point alpha. So I get my 9 more good Ys, but what do I lose? Well, I had 50 good X's. What do I have now at point alpha? Because I went to here. I only have 20. So what did it cost me? The answer is 30 good X's. And try it one more time. Let's go ahead and we'll say that, let's say we're starting at point Bravo and I want 3 more good Ys. What would that cost me? So I'm at point Bravo, I want 3 more good Ys. What does that cost me? So remember, point Bravo means we're here and here. Where are we going to? Well, 3 more. 6 plus 3 for good Ys is 9. So we're going to go to point alpha. But point alpha means we go from 35 to 20. So going from Bravo to alpha, or 3 more good Ys, cost me 15 good X's. Okay, hopefully you guys got it by now. And what I want you to do is, now that you've drawn hopefully a bunch of these combinations and wrote some answers, go ahead down here to where it says, what is this graph showing? And what I want you to do is go ahead and explain what is happening, especially that you will remember it, because you're going to have to calculate these. We have a test in a few weeks, and if you're like, I might forget, many students do. Write a good note to yourself, because you got all the time in the world today. What would make you remember how you did this math? So I've explained it a bunch of ways. You don't have to write it all down, but how can you remember? Use any of the examples I gave. Show any of the math you want. Write any of the words, but explain to yourself so that future you can go right to the notes and go, I know how to calculate this, because this could be multiple questions on a simple idea of opportunity cost. All right. And the last concept, and pause the video now before we move on while you're writing all this down. But the last concept we're going to cover is this graph right here. So pause if you haven't copied this down. It's about to disappear. All right. The last concept we're going to show here deals with specialization. So that's going to be the tone that we use. We're going to call this specialization. That's a C. So specialization. All right, now let's get into this. If we're making things like guns and butter, making guns and making butter is very different. If we're making bagels and roller skates, all the land, labor, capital to make those is very, very different. So what can you do to make sure you understand how to make these things? Okay, well, let's get into it. The answer is this. If we're going to make goods where all the resources for one equal the resource for the other, a good example here is cakes and cupcakes. So what we can do here, oh, interesting. Okay, so what we'd have is, if you think of cupcakes and cakes, what labor do we need? Okay, we need skilled bakers, people who know to bake and work a way around a baking kitchen. What kind of land or natural resources do we need? Well, we need flour, sugar, eggs. You can put chocolate chips in there and several other, milk and other ingredients like that. So if you need that to make cupcakes, what do you need to make cakes? Well, a baker, Flour, sugar, eggs. What kind of capital or machines do you need? Well, man-made goods used to make other goods. You need a mixer, a bowl, a whisk, a spatula, a cake pan, an oven. All of that would be needed for cupcakes, but it's also what you would need for cakes. And because they are so similar, we can realize that all the resources that are good for making one are proportionally good at making the other. Now, it's not equal because one cupcake does not equal one proper cake. But we could say that it's maybe a 12-to-1 ratio. So what we could do is go ahead and draw what would this production possibilities curve look like. It's not going to be bowed out like these other ones would. It's going to be a straight line. Because what we could realize if we put all our resources into making cupcakes, we could have something like, well, we could have 72 cakes, or we could have 6 cakes. So 72 cupcakes or 6 cakes. And it would be essentially a 12-to-1 ratio. But it would be 12-to-1 ratio on the first, second, third, fourth, fifth, sixth cake. So a straight line means that all the resources are just as good for making one good as the other. But if we look a little different and said, all right, what if we're doing something to the effect of, let's call this chairs, and let's make this one socks. Well, the skills to make socks and the skill to make a chair are rather different. The resources and materials and land and kind of ingredients you need to make socks and chairs are also quite different. As with the capital and machines you would need to make socks and chairs. So if we had an economy with a certain amount of machines and a certain amount of labor and a certain amount of natural resources, well, then we'd be in something different. It would not be a straight line like cakes and cupcakes, which are perfectly relatable. You would have a different curve, which would be bowed out, which is like the curve we've seen, okay? So this curve would be bowed out. And what a bowed out curve, this bent curve means, is that you do have specialization. That we have some labor, some skilled workers who are better at making socks. And as you take more of them away to make more chairs, you'll get more chairs, but you'll get less more chairs each time. And you'll be giving up more and more socks. The same would be true as if we went ahead and tried to get the best carpenters who could make great chairs and said, start making socks. Hey, when I say everyone make chairs and my sock makers are making chairs, when I say, hey, go ahead and make me some socks, well, what I'll get is, that's gonna be 30. I'll get 30 more socks, but it'll only cost me 1 chair. So the opportunity cost is just 1. But when I get to, here, I'll give you a different spot, but when I get to here, I'm at 70 socks, but now I'm giving up something to the effect of, if I went from, if I went from here, from 6, I'd be giving up 4 to get 40 more. So I give up 4 chairs to get 40 cupcakes, which means I'm giving up way more chairs to get socks. So what this calls is increasing opportunity cost. But the key point is a bowed out curve is specialization. It means that as we take resources away from socks and more resources from socks, we'll give up more socks to get less chairs, and vice versa. Because some people and resources are better at one thing than the other. However, when we have things like cupcakes and cakes, those resources are perfectly interchangeable. It's probably a good word for you, perfectly interchangeable resources. And so there would be no specialization on any of the resources, and therefore you would have a straight line as your production possibilities curve. Now keep in mind, sometimes you just draw straight lines to make the math easier, but that's more bigger kid economics. So what I want you to do now, finish this paper up and go, all right, bowed out curves, what do they mean? Hint. And why? Why do they show specialization? And a straight line, what does that show? And why? Because resources are the same. All right, once you do that, you finish this side of the paper and you're a bit closer. Follow what your teacher says. Take care, guys.